Picture of all the different size blocks.
Well, gauge blocks.
Gauge blocks.
That's why I use these things all the time for doing all kinds of different things, like setting up stops on drills and all kinds of things. I always use them. Very handy to have.
All to the thousands. Yep.
It's an old set. It's an ancient set, but it does what I have to do. These are some of the punches that I use to punch discs. You can see, and it's done on that kick press I was just showing you a second ago. You can see all different sizes. I've got some hollow tubes and stuff like that. You know, whatever I need for a different size disc, I make up a punch. And there's a whole bunch more punches over here for different size discs. All these are different sizes for whatever I've had to do. Now, the way this thing's work, so that the slugs don't get inside there, I have this. There's a spring. This pushes out the slugs. And I'll be very honest with you, the amount of spring pressure it takes is tremendous. This is a real ballsy spring from a die set, and it's tremendous the amount of pressure it takes to eject that slug when little bits of paper and stuff get stuck up between the surface here. It takes a tremendous amount of pressure to kick out the disc, and so that spring is not overkill, and it's put together like so. And then I got a couple of nuts on the back that adjust the amount that the ejector sticks past the end of the cutting edge there, and of course, once I get it set, I run a jam nut so that it doesn't change. And you can see those ejectors are on that. They're on that. Yeah, they're on a lot of these punches, but that's basically what I use to punch out all the different discs and holes and stuff like that in end discs. This is all the stuff that's been made up over the and all this is tool steel. It's just been made up over the decades.
A lot of different discs and holes I've seen.
Well, you can't buy. You got to make a lot of this stuff because there's no place you can buy oddball stuff for whatever the idea of a tube happens to be. You got to make your stuff. So that's how it's done. Well, that's how I do it.
Awesome. Okay.
This is a small air cylinder press thing I made up using a Bimbus cylinder. It's a 2-inch cylinder, a little regulator, a couple of clippet valves. I had to make these manifolds for myself. They do offer manifolds, but not exactly what I wanted. And basically, this is what I use for pumping out. I work on glass, but that's what I use for pumping out my little rectangles and pumping out small. Anything that uses a comet uses a pump with a 3/4 inch diameter outside. This is for doing my cavity stars. But basically, you got a little, you have the pump goes into a little V block made out of some maple, and it's used for pressing. And there are times where I want this down so I have a reversing thing on there. So there are a few times I want that to stay in the down position, but mostly it's used like this. Again, it's very simple design, cold roll steel base. Made up this piece here, little bracket, also air cylinder, little regulator, and I use every little star that I have made that I put on outside colors onto my headings, either with this thing here. They're all pumped one at a time using this little, and I work on glass. It's real easy to clean off and keep clean. If you don't get, not having a lot of pressure on here, if you don't get some junk on here, it's laying nice and flat. The glass does not break. I also work on some aluminum, but the glass is nice. It just works nice. So that's what I do for anything that I'm going to have a pump with a 3/4 inch outside diameter. Whatever the idea is, this is the setup that I use.
Nice little press.
This is a cylinder that I made up for extracting my motors out of my sleeves. Sometimes when it expands a little bit more, it's difficult to get the motor out of the sleeve. So basically, it's got a, this is all made up. This happens to be PVC, aluminum tube. The piston's PVC with O-rings on it. There's a wiper and an O-ring and then a wiper on top of it right there. And it presses, when it presses, sits in, the tube sleeve sits in B blocks, and up against this top surface right here, there's a steel insert, just so that you're working against a pretty thin wall up there. So there's a steel insert that takes up the four-way valve, you know, very simple. And when the thing is, when the tube is stuck in the sleeve, which this one isn't, but you can get the idea. That's stuck. All you do is and it comes off right in your hand. So that's the deal that I use to that's how I strip out motors out of sleeves if they happen to be stuck. It works pretty nice. It sits on the bench. Very simple to make. PVC. There's O-ring seal here, O-ring seal down here, O-ring seal in the middle here with a wiper. And the piston itself is made out of PVC, and it has an O-ring on that thing. And it works just fine. I've never had any problems with it. The whole thing is bolted together. You can see this is lined up. This is floated in with the nut so that this thing is setting reasonably parallel to each surface. So very simple. A couple pieces of threaded rod, some nice washers. So anybody can see how that's done if they want to try duplicating something like that. Again, the V-blocks were done on the milling machine. And that's the way in which I get out the old stuck pieces.
Hands are a nice motor. Right off the top.
Oh yeah, that's cool. When the lady pyros see this, they go nuts.
We've had some of this like Star Trek that hands you food. Sometimes it doesn't shut off.